Okay, so on this question, we're converting the point with Cartesian or rectangular coordinates. Here it is, I changed the problem, to polar coordinates, inner exact values for r and theta. So let me come down here and show you what it says in the notes. Here are the notes. So converting from rectangular to polar, starting with rectangular, which is Cartesian, you plot the point to see which quadrant it's in, and then calculate r to be square root of x squared plus y squared. So let's plot the point first off, and then we'll calculate r. So maybe I'll plot the point right over here. Which quadrant is it in? Well, it's back and up. So do you see, whoops, that it's going to actually be, back 5 root 3 over 2, up 5 halves. It's going to be in the second quadrant, isn't it? And then we calculate the r. The r will be the square root of x squared plus y squared. So that's going to be a little tricky. So it's going to be square root of negative 5 root 3 over 2 squared plus y, which is 5 halves squared, right? So I just did x, this is x, and this is y, right? Square root of x squared plus y squared. So, okay, so now, how do we square all that? Well, we just square everything. So I'm going to square the 5. That'll become 25. And then the 2 cancels the root to be plane 3, and then square the 2 to be 4. Plus, and same thing here, square the 5, square the 2. 25 fourths. That makes sense what I did there. So again, when it came, you square the 5 and the 2 and the negative, the negative squared became positive, right? This is positive now. Because you square negative, it's positive. And you square the 5, it's 25, square the 2, it's 4. And with the 3, it removes this root. You could say it's, it's square root of 9, which is plane 3. That'll work too. And so what do we get? So we get square root of, that's going to be 75 over 4 plus 25 over 4, which we almost got it here. Bring it down here. That's going to be the square root of 100 over 4, right? Which is the square root, whoops, I have my tool on there, square root of 25, which is just 5. So there we get our r. Our r value, put it up here, is 5, comma. Now we just need the angle. So how do we find the angle? Well, it says down here for the angle, find the angle in degrees or radians. The reference angle is inverse tangent of absolute value y over x. Okay, so I'm going to go, okay. So let me put a line here. Separate all this stuff. We're done with that side. So now the reference angle is inverse tangent absolute value y over x. Okay. So the reference angle is inverse tangent absolute value. What's y? 5 over root 2. 5 over 2 over x, which is negative 5 root 3 over 2. So it's y over x, like that. And so now, what do we do with that? Well, do you know that when we have fractions over fractions, we have to grab the 1 on the bottom and flip it upside down? So it becomes 5 halves times 2 over 5 root 3, negative 2 over 5 root 3. Now, why is that? I want to make sure, I don't like to give you rules without reasons. You know 10 divided by 2 is 5. And that's the same thing as if you take 10 times a half. Half of 10 is also 5. So in other words, dividing by 2 is the same as multiplying by the upside down of 2, right? And so that proves that dividing is just upside down multiplying, which you probably already knew. So that's what I just did here. Dividing by this is the same as multiplying by its upside down. And it's easier that way. So now these 2's will cancel, these 5's will cancel. And so where are we at? We get the reference angle is inverse tangent of absolute value of what? What's left? Minus 1 over root 3. Now, right, because the root 3 is left on the bottom. So that's inverse tangent of actually positive. Let me change the color here. Positive 1 over root 3, right? Because the absolute value makes it positive. Now, here's the trick. Here's what I really want to tell you. Change to degree mode. You might say, why, Mr. We're trying to get a radian answer. Is it right here? Radians. I know. And that's where we're going. But change to degree mode on your calculator because we want an exact answer. Did you notice that they want an exact answer, not a decimal? You see, if you're in radian mode and you hit inverse tangent, you're just going to get a decimal. So we're going to have to go to degree mode, get an exact degree answer, and then change back to radians on the unit circle. It'll be a piece of cake. This is the way to go. So hit the buttons on your calculator. The reference angle will be inverse tangent of positive 1 over root 3. Hit the buttons on your calculator. Make sure you're in degree mode. Put it in exactly as it is, and I'm in 30 degrees. 30 degrees. It's an exact value. Now, hold on. That's still just the reference angle though, huh? So we have the reference angle is 30 degrees. Now, how do we get to the actual angle? Well, that's the notes. Currently, we only have the reference angle. To find the actual angle, it's based on the quadrant. We're in the second quadrant, so the actual angle is 180 or pi. We're using degrees right now, minus the reference. 180 minus the reference, right? We're in the second quadrant. With me right here, that's why we graphed it in the beginning. It's backing up, second quadrant. So second quadrant, so then that means the actual angle is 180 minus the reference angle. So the actual angle is 180 minus 30, which is 150. Now, that's the actual angle. That's the exact actual angle. Now, change to radians because they wanted exact radian answer. What is 150? Just go to the unit circle. Whoops. Let me put the unit circle in here for you. Let's go to the unit circle, grab it, and it'll be done. So 150, right here, 5 pi over 6. See, the unit circle connects for us degrees and radians, exact values. It's bang, that quick. There's the exact value, 5 pi over 6. So we just go 5 pi over 6, done. See, that's an exact answer. Whereas if we'd done our up here, if we'd been, that's why we had to go degree mode. If we'd been in radian mode, we got a decimal and it's not exact. That's exact now. 5 pi over 6, that's the exact radian angle. And so that's what makes that one hard. So again, what did we do? So first off, we found the r, which is square root of x squared plus y squared. We had to square a fraction, which means square the top, the bottom, and then the root cancels the root. So we get this. Same thing here, square top and bottom, and then add them up. Square 25 is 5, so we get the r. And then the angle, the reference angle, is the inverse tangent of absolute value y over x. But y over x, it's a fraction, flips up, 2's and 5's cancel, negative 1 over root 3, but absolute value makes it positive 1 over root 3. Then change to degree mode, because you want an exact answer, not a decimal. So inverse tangent in degree mode, 30 degrees of positive 1 over root 3 is 30 degrees. And then the reference angle, that's the reference. To find the actual, you got to go to the quadrant. We graphed it up here and found that our original point, back 5, root 3 over 2, up 5 halves, is the second quadrant. Second quadrant, those little formulas there. second. So the actual thing here because of this was because of second quadrant, right? It's 180 minus 30, 150, and then the exact, that came from the unit circle. We just went to the unit circle and said, oh, where's 150? Right there. What's the radian? 5 pi over 6. And we got the exact radians. So there we go.